This is numbers 1 through 6 on your Unit 1 study guide. In the very first problem we have here, you'll notice that we have a polynomial added to a polynomial. When you are adding polynomials or even subtracting polynomials, you need to combine like terms. To find your like terms, you see you have x squared. That will go with the other x squared. So 5x squared plus 7x squared is 12x squared. Then you're going to look for your terms that have x to the first power, like this negative 8x and like this negative 9x. Negative 8x minus 9x is negative 17, and you keep the x. And finally, we have just our constants, our numbers. So we have negative 6 minus 3, which is negative 9. Now I want you to look at this because notice that I never added the exponents on any of these. When you're adding or subtracting with like terms, remember you combine the numbers but you keep the variable exactly as it is. So in this case we did not make x to the fourth when we added the 5x squared and the 7x squared. We kept the x squared. And all we did was add the coefficients in front, so 5 plus 7 is 12. And again, leave the variable as is. If you look at number 2 is slightly different because you have a subtraction sign here. So there is one extra step involved. You have to distribute that subtraction sign to every single term on the inside. So you leave the first polynomial, in this case it's a trinomial, alone. And then you're going to distribute the negative. Negative times 6x squared is negative 6x squared. Negative times positive 5x is negative 5x. And then negative times a negative 11 would be a positive 11. And now you're going to combine your like terms. So you see the x cubed and nothing else has an x cubed, so you're going to bring it down. Then you look for your x squared, and the only one that you have is this right here. So make sure you take the sign with it, so it's like negative 6x squared. So we took the sign with it. Now look for your x's. We have 5x and we have negative 5x. 5x minus 5x is 0. It cancels, therefore we don't have to write the x. And then finally look for your constants. Negative 9 plus 11 would be positive 2. And then that would be your final answer. On number 3, whenever you're adding and you have radicals, you need to make sure that the radicands are the same. In this case they're not, but you're not necessarily done because the square root of 8 is not the prime factorization. It's not the prime number, so we do need to do the prime factorization. So we come off to the side, we'll take 7 square root of 8, and we say we've got 2 times 4, so that's prime number. Then we have 2 times 2. So on the inside, we have 7 times the square root of 2 times 2 times 2. And remember, you're going to circle out one twin and pull it out, and you'll multiply it times the number on the outside, so that would be 14 square root of 2. So this 7 square root of 8 is equal to 14 square root of 2. Then we have plus 11 square root of 2. Now our radicands are the same. So you keep the radicand, and then you're going to add 14 plus 11, and so we're going to get 25 square root of 2. Alright, on number 4, it's very similar because you'll notice that 50 is not a prime number, so we might be able to simplify that. So we come off to the side and we're going to simplify the square root of 50x. That would be 2 times 25, and that would be 5 times 5. So then on the inside we have 2 times 5 times 5, and then don't forget your x. The only thing that comes out is this 5. So we have 5 square root of 2x. So we can say that this is equal to 5 square root of 2x. And then notice 5 is already prime. We can go ahead and simplify this x cubed inside. So if you think of it this way, we have the square root of 5 times x, x, x. Take out one of those twins, so we'll have, bring down that negative, we'll have that 14. We're going to pull out one of these x's, but what's left inside is 5 and x. Now if you look at this, the radicands are not the same. 2x is not the same as 5x. Therefore these cannot be combined, and that's as far as we can go, so that is your final answer. Then we go to number 5. Again, notice that we've got 2 radicals that we should simplify first. to see if maybe our radicans are the same. So we're going to go ahead and do the square root of 27, which is going to be 3 times 9. Then do 9, 3 times 3. So then on the inside, we'd have the square root of 3 times 3 times 3. There's a twin. Pull it out. So what that makes is 3 square root of the only thing left inside is 3. Oh, and we have to multiply it times that 4. I missed that 4 before. So that would be actually 12 square root of 3. If you're wondering where I got the 4 from, it came outside the 27. Then we got to do 15. Now 15, if you'll recall, is made up of 3 times 5. That you can't do anything with. They don't have twins. So we're actually just going to bring down our 16 square root of 15, and then this would be your final answer right here. Finally, when you look at imaginary numbers, it's the same idea as the polynomials. So you will bring down the 5 minus 4i, but we're going to distribute this negative to both pieces. So it's like negative 7, and a negative times a negative would be positive I. Now we combine like terms. 5 and 7 are both constants, so we can do 5 minus 7, which is negative 2. And then negative 4i plus I gives us negative 3i. And remember, you want your answer to be in standard form, so it's a plus bi, so the I term is last. So here are our answers for the very first 6 problems on our study guide.